In this example, we want to evaluate the expression when x is equal to 4. And these look a little bit more complicated than example 1, but if you know the principle of substitution and your order of operations, these are actually quite easy. So let's take a look at this first one, and we've got an x here and an x here. Now, a key thing in algebra is that in the same problem, the x has to be the same thing. Yes, it's a variable, but if this x is 4, that x is going to be 4 as well. So let's see if we can set this up by substitution. We'll take this x out, and we'll substitute in something that the x is equal to, which is 4. We'll keep our division sign, and it's important to keep your horizontal fraction bar in this case. Don't change that to a backslash or a division sign. It's very important that you keep that horizontal fraction bar. And we've got 3, and then the x is out, the 4 is in, and then we'll add 2. Interesting thing about this problem is we have a couple different grouping symbols. Not only do we have parentheses down here, but we also have this horizontal fraction bar. The horizontal fraction bar signifies two different things at the same time. One is, yes, it's division. So we'll take whatever's in the numerator here, which is the top of a fraction, and we'll divide that by whatever's in the denominator of this fraction when we get to that. But I also need you to understand this as a grouping symbol. So we need to do what's in the numerator like it's a separate problem on its own, and then we'll also work with the bottom. Turns out that we can do our operations in the top and in the bottom at the same time. So let's do this 9 times 4, which is 36. If you prefer to wait, you wouldn't be wrong. This just will help us sometimes in working the problem a little bit quicker. And then we've got 3 times 4 plus 2. And we need to do this parentheses, what's inside the parentheses here first. So 4 plus 2 is 6. And then I'm going to continue this problem up here on the top. I'm kind of running out of some room. And then, let's see here, we've got some multiplication to do. Remember, this horizontal fraction bar means work in the top separately, work in the bottom separately. So the top part of this fraction, the numerator, is already simplified, it's 36. But the bottom is 3 times 6, which is 18. You don't want to leave your answer here if it can be simplified further. Some fractions can't, like 7 over 5. That would just be 7 over 5. You could change the form of it, but you couldn't really simplify it. 36 over 18, however, can be simplified. So 18 goes into 36 2 times, so 36 divided by 18 is going to be 2. For part B here, we're going to do the same thing. This time we've got an exponent or square here going on, but it's very easy to work these problems also if you just take the x out and substitute in the 4. Whenever you have an exponent, I always like to substitute using parentheses. This will become very important when you have a negative value that you're substituting. In this case, it doesn't make too much of a difference, but I think it's a good thing just to get into the habit of substituting using parentheses. So let's use our order of operations here, and if you're watching this video at home or maybe in school or wherever you are, make sure that you're thinking ahead. Make sure that you expect something to happen, and then verify if that's right. If it's not, you should be asking yourself, why is that? Why did he do that? Why is that operation being done before the other? And check that out. You can look at the past videos or any other videos online as well. This is an order of operations problem. We definitely want to do the exponent here before we mess around with the subtraction. So let's do the 4 squared here first, and 4 squared is the same as 4 times 4, which is 16. Then we need to subtract 13. So 16 minus 13 would be 3. Last part of this problem here, this is C. And so in C, we've got another one of those horizontal fraction bars. And remember, the horizontal fraction bar indicates division, but also it is a grouping symbol. Let's substitute first, though. And if we do that, we're going to have 10 times 4 plus 1. Again, the operation that's in between the 10 and the x here is multiplication. We've got our horizontal fraction bar. And then we have a 4 and then plus 1. Let's work with the numerator, and then we'll also work with the denominator separately. So 10 times 4, we want to do that first before we do any addition. 10 times 4 is 40. Then we'll add 1. And in the bottom we've got 4 plus 1, which is 5. We'll continue that up here. So 40 plus 1 in the numerator is 41. And that's divided by 5. You definitely can leave your answer like this. If a problem that you have in real life, yes, you might use this in real life. Or if a problem in math class is needing a different form of this answer, then you can easily change this into a mixed number. So if we look at 41 divided by 5, we can ask ourselves how many times does 5 go into 41? And the answer here that you should get would be 8, with 1 left over. 8 times 5 is 40, but there's a 41 up here. So this would be 8 and 1/5 as a mixed number. And then we could also state this as being 8.2. So either one of these would be acceptable. We really don't know a context for this one. So be comfortable moving between each one of these forms.